So hello everyone, welcome to this video. This is a video about CS61A, the structure and interpretation of computer programs, which is the introductory computer science class at UC Berkeley. About 1,800, 2,000 people will take this class every semester. It is the largest, this past edition of fall 2019 CS61A was, as far as I know, the largest on-campus class of any class in an American college ever. 1,836 people, I believe, were in last semester. Despite the fact that so many people take it, a lot of people still head into the class with a lot of questions. They're not sure what the class is like, how it works, what you get taught in it. So this video is just going to be a quick overview of the class. Some tips on how to succeed if this is your first time. I took the class with just a few months of programming experience. I started learning programming over the summer, and I am now very interested in becoming a CS major. I pulled out an A in the class, just barely, but it's certainly possible, even if you've never programmed before. So let's just go over the class, see what it's like. So this is the class homepage. This is your hub for everything happening. At the top here, these are the announcements of the day. Announcements. If you take the class, you'll know what I'm talking about. So it'll list the date, and then it'll list all the important bullet points for this day. This is like the last announcement post, but this is what it might look like on a typical day. It lists out the homework that's due, CAT's composition revisions. You'll know what that means later on, and then you can get all of these links, the lectures for the day, for the week, worksheets, as well as some resources that you might find useful. And you can cycle back and forth between them. So just going to go very quickly over the syllabus. The CS61 series is an introduction to computer science. CS61 concentrates on the idea of abstraction. 61B deals with the more advanced engineering aspects, such as constructing and analyzing large programs, and 61C focuses on machines and how they execute the programs. CS61A primarily uses Python free. Mastery of a particular programming language is a very useful side effect of 61A. However, our goal is not to dictate what language you use. Instead, our hope is that once you've learned the concepts involved in programming, you will find that picking up a new programming language is but a few days' work. So I'm not here to parrot those points. It's just to let you know what the class is like. There are two other classes you might take at Berkeley before CS61A. CS10 is a very bare bones introduction to CS based on a visual programming language called Snap. But of course, as I said, it's not a requirement for you to have lots of programming experience. In order to succeed in 61A, you might find CS10 useful, but it's certainly not a requirement. Data 8 is an introduction to data science. I took this class concurrently with 61A. I personally found 61A the more interesting and even at times the easier class, because 61A has been taught for a long time. It's been taught at Berkeley in one form or another for about 30 years now. So I think it's a very well-refined class at this point. So yeah. So the class consists of free 1-hour lectures a week. Okay, 50-minute lectures a week. They're on Mondays, Wednesdays, and Fridays in our case. I don't think it's ever been taught on another day. You can either come to class as usual, or like the majority of 61A students, you can actually just watch the video. This video is open for everyone. You don't have to be a Berkeley student even to take this class. You can just watch the video.
61A, lecture number 37.
And then they're split up into intuitive concepts, usually based on like some subtopic of the particular day. Syntax trees, grammars, yeah. You'll understand all of this once you start taking the class. And then next to each lecture, there's always the slides, which are in PDF format. My computer is freezing up. Oops. Okay, we're going to reload that. So yeah, and then below here, there's a very useful calendar. You can see what topic was for that day. Yeah, and there's always the slides in PDF format and the files, Python files that were used in demos in case you want to play around yourself. And you can also see which link, which part of the textbook that day is linked to. And yes, the textbook is available online for free. You can just open this link and then you can see the online textbook, which is again open for everyone. You don't have to be a Berkeley student to take it, to open it. There is also that week's lab and discussion links, as well as homework at the end. So in addition to the lecture, you will also have lab and discussion every week. You don't have to come to them. You're only required to come to 10 total labs and discussions combined. Labs or discussions combined in your about 15 weeks of class, I think. So that's about 10 out of 30 that you have to come to, about a third, in order to just get the participation credit. The rest of it is what they call recovery points. You can read that up in the syllabus. That's not the point of this video. You can see the lab and the discussion. And the homework is at the end, and you can see the due dates. Labs are always due on Friday. Homework, I believe, is almost always due on Thursday unless there's an extension. And you can do the labs and homeworks either on the school computers, or most people just choose to do them on their own laptops. So with every lab and homework, you can open the website. Excuse me. You can open the website. You can open the link, and you will get a very basic overview of what it's like, and then you can download the file here. Save, and then you can just open it in your favorite archive or whatever. That is not the point of this video, but basically I like to keep everything in a very neat format. I've downloaded the starter files for every homework, so you can see here as well. Homework 1, you can save it, open it wherever. I've kept it in this nice folder where I have a list of all my homeworks and labs as well. And each of these labs and homeworks have the files that they need to automatically grade your homework, as well as your homework itself. This doesn't look very clear right now, but it will always tell you which file you should edit. For example, in this case, it says that define this function that does this, and then you should edit it in which file. I think it does mention at some point that you have to edit homework1.py. I'm not allowed to show you the solutions, but basically what happens is, after you edit this file in your favorite text editor, you can open this up in the terminal, and as they teach you here, you can just copy this command. Excuse me, this is proving very difficult to copy. Okay, whatever. And you can see that if it is correct, it will say test cases passed, and then it'll also automatically back up to whatever user account you've logged on your computer. If this is your first time, the computer will automatically ask you to set it up. It's very easy. But it also does mean it only it also works locally, even if you're not in the class, so it will work. So yeah. So this is And then after you're done, you can type Python free OK, and then you just type submit, and it'll automatically submit your homework after you're done with everything. So it's a very easy system. If you get something wrong, like for example, let me purposely screw something up here. And then we open it up in terminal. It will show me what was the correct solution, as well as what my system got. So you can see it's very intuitive. This is all very self-explanatory for the first CS class, which I think is useful. This same structure goes on for the entire labs, everything, projects as well. So it's very friendly. If you put in the time, it's certainly possible to get very good grades. In fact, most people that take 61A will usually get full grades. We'll usually get full grades on the homework, on projects, on labs. That is pretty much what most people tend to do. And that's, of course, very useful because you see here, based on the course counting sort of thing, the course is out of 300 points. Your projects, homework, and labs and stuff are worth a total of 135 points. So if you have 135 points, you are getting very close to just passing the class based on effort that most people will get. That also does mean that the real differentiator of 61A is not how well you do in projects and labs and homeworks, because most people, again, will get perfect. It does mean that the main differentiator is the exams, and exams are very difficult. So 61A, however, is very useful. The staff are very helpful, and they let you, and they provide all of the past papers from the exam, all the past exams, for you to practice. And they even provide a very neat list of topics taught in the class, some guides for them, some practice problems, and if you're feeling ready, some practice problems from the exams with labels of which question they are. So that is certainly very useful if you're a student. And there's even some very helpful links here. 61A exams are very tough, certainly for some people. I will try to see if I can still find the grade distributions from the class. I'm going to log into to my Piazza account where they put up these posts. CS61A. So we're going to find a midterm 1. Is sometime in September. There you go. Midterm 1 is graded. Okay, there you go. This is the grade distribution. You can see that out of 40 points, there were people that got a maximum of 40, median of 28, mean of 26.85, and there was one person who got 1.0 out of 40. So there are people that do really badly on these exams. I'll also try to pull out the midterm 2 grades. Here's midterm 2. There was someone who got a 0, and there are people who did pretty well on them as well. So you can see there's a very wide range of results for these exams. And the finals, there are the grade distributions here as well. And you can see people did pretty well on it as well. No one got a perfect score in this exam though. So in order, so as the syllabus says, you need 285 points out of 300 to get an A. You need 270. you get about a handful of extra credit. You get a handful of extra credit points, as they say. We got 10 this semester, exactly 10. There were some past semesters that got more. It depends on how well the class is doing. Even though CS61A is not curved to the point where, the top 15% will always get an A, they do try to use these extra credits and bin shifting, which we'll talk about later, to sort of get the grade distribution that they want according to department guidelines. So yeah, here is the grade distribution. So you can miss about 15 plus 10 extra credits, so you can miss about 25 points in the whole class out of 165 on the exams in order to get an A, which is difficult, but that's exactly what I did. All of your exams are marked on Gradescope, and I'm going to show you what I got on these exams, just to give you an idea of how people typically do. I should certainly note that this is not that I did a little better on my. I did a little better on the final than people typically do, compared to their midterm results. Like, I did better on my final than my second midterm. Hold on, I kind of forgot my password. Okay, so I don't remember my Gradescope password. I had to open them on Chrome, which saves my passwords. So you can see this is my midterm 1, midterm 2, and final scores. I lost less points on the final than I did on midterm 2, even though this is a much larger exam. So I'll just show you. You can fully see what your exam was like, where you missed out on points, and I think it provides a very good learning opportunity for you. So this is what the exams are like. They usually consist of 3 big sections. The first is what would Python display. So this tests your Python knowledge. If all of these commands here are executed, and then you execute these commands here in the tables, what will it display on the computer if you had executed these commands? And then after that, that's worth about 10 to 16 points usually, 10 to 20. And then the second part is an environmental diagram. An environment diagram is sort of them asking you to visualize what and how the computer thinks. So when you execute this code here in the box, what names get assigned to which values or objects or functions, and what happens inside those functions. So you will learn how to do this in lab and discussion. Certainly you will get better at it. It's something you will have to get better at, but I think it's very useful in the end because it helps you sort of think like a computer when you're writing programs. It's not easy, certainly, but it's a level of it's an intuitive understanding that you'll eventually get from learning how to do environment diagrams. And the rest of the test is open-ended code writing questions. Code writing questions are, they provide you sort of an objective. Implement the again function, which takes a function f as an argument. The again function returns the smallest non-negative integer n for which fn is equal to fm for some non-negative integer m that is less than n. So yeah, so they will provide some background on the question. And most importantly, they will also provide, they might provide some helper functions that you can use. But more importantly, they will provide you a skeleton code. So it's not a fully open-ended question. You're not left completely to your own devices, but instead they've sort of provided half of the code and you have to fill in the blanks. I personally think that this makes the test harder because it forces you to not only think to not only think in a problem solving sort of way, but it also forces you to think and solve the problem their way. You have to understand how they want you to think. And sometimes it's not even necessarily the best way. If you're really good at programming, it might come to this situation that you know of a way to write this solution much more succinctly or much more efficiently than what they've given you, but you have to stick with the skeleton code. There is no way you can't do that. So certainly it helps to look at the test cases that they've provided. And again, these are intuitive understanding. This is an intuitive understanding that you understand eventually the sort of questions that they like to give and how to solve them once you've taken the class for a few weeks. Certainly study very hard for these tests, and you'll be able to do very well. You can also make regrade requests if they've marked it wrong, but I never got any regrade request points off of my tests because I find that they mark them really well. This is my midterm 2. You can see very similar structure. This is CS61A. It's a very good class. Certainly, I couldn't have asked for a better introduction to computer science than this. I found that I learned a lot in my 16 weeks of the class. I emerged with an A despite having very little prior programming experience. So I think, and I devoted about 10 to 15 hours a week into the class, which is certainly not abnormal for a technical class at Berkeley. So as long as I think you come into the right mindset, ready to learn, ready to sort of get to know the concepts that are taught, because certainly the class is very fast paced, and you shouldn't come in thinking that I know everything, I'm going to ace this class. You should always come in with an open mind, ready to learn more, and I think you'll do very well. Practice very hard for the tests, and you will do very, very well in the class. I wish you future CS61A students the best of luck. Professor De Niro is amazing, and if you get him, certainly it will be one of the best classes you'll take at Berkeley. Enjoy the experience. Good luck, and please leave a comment down below if you have any questions. Thanks for watching.